This video covers Griffiths 1.2.5, the curl. So just like we can calculate the divergence of a vector using the del operator, we can also calculate the curl of a vector using the del operator. The curl of a vector is found by using the cross product. Okay, so that curl of my vector field is found by taking the determinant x hat, y hat, z hat. The first line is my del operator, d dx, d dy, d dz. And the second line is my arbitrary vector field, vx in the x hat, vy in the y hat, and vz in the z hat. All right, so to calculate the determinant, we go ahead and break it up into all the components. X in the x hat, d vz dy minus d vy dz plus y hat, d vx dz minus d vz dx plus z hat dvy dx minus dvx dy, and that's the curl. Notice that the curl is still a vector. Okay, so what does a curl represent? The divergence represented the accumulation or the loss of material in a flow. The curl represents rotations in the vector field. So if I have a vector field that looks like this, I'll have a curl, a non-zero curl. All right, so let's go ahead and do an example. In figure 1.19 of your book, they have a field that is in the xy plane, x, y, z, and it is big for positive x. It is big and negative for negative x, and it gets smaller and smaller and bigger again. All right, and that exists over all space. I'm not going to draw all the vectors. So let's assume that this vector field can be written as v is x in the y hat direction. All right, it gets bigger in x and it's pointed in the y direction. Let's calculate the curl. The curl of that, I'll just write the determinant, del cross v, x hat, y hat, z hat, d dx, d dy, d dz, and it's only in the y hat, it's x in the y hat. What am I left with? Okay, I don't have any x component. Those are all zeros. I don't have any y component. I'm only left with a z component, and the value of that is 1. So I'm left with the z hat. So the curl of my vector field is 1 in the z hat. Now, let's rationalize that result. We picked an arbitrary magnitude for our field, but so maybe we can't understand that completely, but can we pick the direction? All right. Notice if you were to go ahead and use the right-hand rule to describe the motion of lines in your drawing here, you put your hand in the direction of one of the field lines and you curl it towards the other field lines. And that's using your right-hand rule, and that would mean your thumb would point in the positive z hat direction. So just like the traditional curl between two vectors, the traditional cross product between two vectors, the curl, the direction is chosen by the right-hand rule.